All right, this is Solving Systems Day 5, and we're going to move into multivariable systems. So past a 2 by 2, two variables, two equations, we're going to move into a 3 by 3. So just adds kind of one more element in terms of substituting or elimination. Doesn't really change what your process is. You just have more to do. So kind of just starting with some visuals. How much does each shape weigh? So I'm going to just go with, this is 2 blocks and 1 sphere. Shouldn't have picked S, it's a terrible letter. And then that weighs 8 pounds, 8 ounces, I don't know. And then we have 3 spheres, and they weigh 12. So it's kind of easy to figure out how much a sphere weighs. Each sphere is 4. And then I can just take that off of there, divide what's left, and I find out that my blocks are worth 2. Sounds pretty easy. That's a 2 by 2, pretty straightforward. Here we're introducing a third shape, so the cylinder, and 3 different scenarios that can happen with these shapes. So I'll let the cylinder be an X, box be a Y, and then the spheres will be a Z, just to kind of keep them all straight. So I've got an X plus a Y equals 13. On this one I've got an X and a Y and 2 Z's equals 21. And then here I've got a Y and 2 Z's for 14. So what's interesting here is there's a couple of different ways you could actually look at this one. You've got an X plus Y equals 13, so you could pretty much just take this out and put a 13 there. So I could have 13 plus 2 Z's equals 21. Could go for it that way. This says that Y plus 2Z is 14, so I could actually replace all of this and put a 14 right there. So I could have X plus 14 equals 21. So kind of a couple of different ways where you can take known information, like this amount is the same as this, and that's 14. So I can kind of eliminate that in an effort to figure out the value of one of the shapes. So in this case, the X will just be 7. If I use this, subtract the 13 and then divide by 2, I would get a Z of 4. And as soon as you know one of those, you can find Y easily. So put a 7 there, just subtract my Y is 6. So that's how much each of those shapes weigh. One more, a little trickier, as I only have 2 variables in each one. So I'm just going to let this be X because it came first, and then Y is the cylinder, and then Z will be the box. So here I've got an X plus a Y equals 7. Here I've got an X and a Z equals 6, and then here I've got a Y and a Z equal 9. So in this case, nobody really overlaps like the last one. I didn't have these quantities that I could kind of slide into place. These are a little more way stripped down, and nobody kind of really fits anywhere. So what I'm going to do is just take one of these equations and kind of do what we did in substitution. I'm just going to solve one of them for a variable. So I'm just going to take this bottom one and I'll just solve for Y. So Y is going to be 9 minus Z. Not too tricky. All of these are pretty straightforward. And then I'm just going to take that and plug it into the only other place where Y shows up, which is right there. So X plus, and then I'll have 9 minus Z equals 7. Well, that's going to cause a little issue because it didn't eliminate a variable for me. I'll minus the 9 over, so I ended up with X minus Z equals negative 2. Okay, but I'm kind of used to being able to solve and getting one number right away. All I ended up with was another equation, which is okay. I've got this second equation, the X plus Z equals 6. So these two are kind of the ones I'm going to work with now. This was the bottom one. I had solved that, plugged it in. So I've already used the top equation. So here's what the top equation made, and then the second one. And they're pretty close to each other. So I'm just going to take this one and solve for X. So X is going to be negative 2, and then I'm going to plus that Z over to the other side. And then I'm just going to take that and plug it in here. So it's just a lot of solve for a variable, plug that into another equation, and kind of keep going till you run out of, or till you eventually solve for something. So this is just going to go in for X. So negative 2 plus Z plus another Z equals 6. So add that 2 over and 2 Z's, that'll be a Z is 4. Now I can kind of back substitute. So I'm going to take that 4, put it right there. Negative 2 plus 4 is 2, so that means my x is 2. And then I can just take that 2 right here, subtract 2 on the other side, so that means my y is 5. So 3 variables, 3 equations, just kind of adds the amount of substituting and plugging back in you're doing. We can also do this system by elimination. So I could have maybe multiplied this row by negative 1 and then eliminated your x's, or eliminate your y's. You could have attacked any variable that you wanted to go after. Visually, what are we looking for when we have 3 equations, 3 systems? Is we're usually trying to find where they intersect at just one point. That's kind of like this. I ended up with 1 point, 1 x, y, z, that worked. 1 x, y, z, that worked. Sometimes we get an infinitely many solution like we have in the past, where they kind of, like these two equations are going to be parallel to each other, which means that they are, that they'll never touch, but then they intersect with the third one and they make a line, so you'll have an infinite number of solutions. You could even have ones where they don't touch at all, so all 3 are parallel, there's no intersection. We will do some like that where you have no solutions. And then this one has actually touching in 3 different places, connecting in 3 different lines, so lots of solutions there anytime we get a line. So let's practice it just as a basic math, no pictures, no shapes. This one's just called a simple back substitution, where you kind of already know one of the variables. So when you're setting up your answer, which is what we're looking for is a point, that 2 is going to go in the z spot. And then our job is just to kind of use that z to substitute and find the next value. So 1 plus 3 times 2 equals 5. So that means y is negative 1. And then using both of those, plugging into the top equation, 2 equals 9. So we've got x plus 2 plus 6 equals 9. So that means x is 1. So that's a pretty simple, nice and easy back substitution. Kind of start with one variable, or sorry, yeah, one solution to one of the variables and then plug it back in from there. Got one left on the next page. This one looks a little more complicated. Got a lot more going on. There's a variable in every spot, like every column. I've got 3 x's, 3 y's, and 3 z's, and then 3 answers that you're equal to. Though what we're going to try today is I'm going to try actually elimination on this one. So earlier when I did substitution, I did that because I had already actually eliminated variables. Like I was already down to 2 variables. And here we already knew 1 answer, so I was able to just kind of substitute those. When I have all 3 variables in 3 equations, elimination is usually the way to go. It does get a little busy trying to solve these, but you can pick an equation, solve it for a letter, plug it into the next, solve again, and keep plugging in. You can absolutely do substitution. I'm going to try elimination. So for elimination, you want to look at any of the variables that kind of already match. So these guys don't match. I can't eliminate any one of them. Here, they do kind of match. I have a positive y and a negative y. They would cancel each other. Same thing would happen here. Z's are also a good candidate. I have a positive z and negative z. I could cancel those as well. It doesn't matter which one you pick. I'm going to pick to get rid of the y's, and we're just going to see what happens. So I'm actually going to give myself a visual cue. I'm going to say I'm going to put these 2 together. I'm adding them. And then I'm going to rewrite the whole system, which for some of you is going to be like, why am I writing this? And that's okay. I have found I have a lot more success. Students have a lot more success when they write out every step that they are doing. Lots of times you'll just start to work in a circular motion and you can't quite remember who was being multiplied or who was being added. So if I could suggest that you just try to write down every step that you do, even though it will mean that you use a little more lead than you're used to. So 2x minus y plus z equals 3. Now when you add 2 equations together, you replace the second one, or the bottom equation. So the fact that I'm adding these 2 together means that I'm going to replace the third equation. So 2x plus 3x is 5x. Negative y plus y is 0 y's. And plus z minus z is also 0 z's. So that was kind of nice. And then 3 plus 2 equals 5. So I need that. So right off the bat, I already know what my x is going to be. Just divide both sides by 5, and now I know x is 1. So as I go to solve, I know my first position is a 1. Now I'm looking at my other 2 equations, and I can put 1's in there. I totally can do that. And then bring those over, and then I've got a little 2 by 2 system, y's and z's. And you can solve that like a regular 2 by 2. I'm going to just continue doing elimination here is the path I'm going to choose. So I can already see that these two y's will go away if I just put these two equations together. So I'm going to add these two. Oops, I just noticed a mistake. That was a 3, this should be a 3. When I'm talking and writing, I sometimes make a mistake. So I'm going to add these two together. So x plus y plus z equals 6. And then when I add them, x plus 2x is going to give me 3x. Y plus a negative y is actually going to go away. And then z plus z is going to be 2z's. And then I'm going to add these two together, I'm going to get 9. So don't forget to add the numbers on the other side. And I'm going to carry along my 5x equals 5 just to keep my system a 3 by 3. Now it's looking great. I already know what my x is. This next equation has an x, which I can plug in for, and then I'll be able to solve for z, and then I'll be able to continue back substituting into the other 3 spots. So let's take my 3x. We know that's going to be a 1 plus the 2z equals 9, just taking that second equation. I'm going to solve that, so just subtract my 3 over. Looks like my z is 3. And now my job is to take the x value and the z value and plug it into the top equation. So my x value is a 1, we're solving for y, z is a 3 equals 6, so just using that top equation, and my y is 2. So what we're doing today is just some gentle elimination and a little bit of back substitution.